Hello, my name is Connie Liu. I'm an undergraduate at MIT, and today we're going to be doing a worked problem about carbohydrates. So first we're going to be looking at different monosaccharides. And right now what you see here is a glucose in two different forms. So first on the left side we have the linear form, and on the right side you can see the ring form. So often, monosaccharides can come in both of these types of forms. They can either be found in a linear structure or a ring structure. But for the most part, they favor the ring structure because it is much more stable. Also, you can notice that there are 6 carbons in each of these, and those are usually numbered to indicate which carbon you're talking about. So this top one is called C1, and that's the one with the O and the H on it. And then over here, you can find the same thing on the ring structure. So this one would be carbon 1. And then as you go down, you get 2, 3, 4, 5, and 6. And then the same thing happens for the ring structure, where it just goes all the way around the ring to indicate to you which carbon is which. So as you can see, these carbons correspond to each other and kind of help you keep track of which is which within the changes between the linear and the ring structure in this equilibrium that we have. So again, the ring structure is usually favored because it is more stable. So that's the one you're mostly going to be seeing. So second, we're going to go into a little more depth about the dehydration reaction that allows for polymers to exist. So the monomers involved in carbohydrates, the monosaccharides, have to undergo a dehydration reaction in order to join together and form a disaccharide. So here we have 2 glucoses, and if you combine 2 glucoses, you get a maltose. And then again, maltose is a sugar that's usually found in, say, beer. And then you can tell that from this root word of malt. So there's malt in beer. So when these 2 glucoses are combined, the H here and the OH here combine and come off of the two glucoses, and at that point a linkage happens, and this is called a glycosidic linkage. And this glycosidic linkage ends up linking the 2 glucoses by just a simple bond between the oxygen that is left. And then the other product that comes out of this is water is produced. So here you have water coming out of that reaction, thus why it's called dehydration reaction, and then only the oxygen left holding the 2 glucoses together to form this new disaccharide.